All right, is the notes for 6-8. This covers the quadratic formula. So in our previous lesson, we learned how to solve quadratics by completing the square. And now we're going to solve by quadratic formula. So both are accomplishing the same goal, just different methods to get there, and some are more useful in different situations. So this is the quadratic formula. If you missed the song in class, make sure to ask someone and they'll help you out with that to help you memorize it. So in order to use the quadratic formula, you have to have it in standard form. Quadratic, again, means the highest power on the x is a 2, it's squared. And you also need to make sure it equals 0. Now in the equations, the a, the b, and the c are going to be replaced by numbers, and we'll see that as we come. But the important part is make sure that it equals 0. And again, this quadratic formula was found by completing the square. It's not just a made-up formula. If you use our method of completing the square with this formula, you would derive the quadratic formula. So as we do the first one here, first check, is it equal 0? Yes. So the second is, here's the standard form, and identify the a, b, and c. So I have that here. A was 5, b was 12, c was 3. And then you're going to plug them into that quadratic formula. So the opposite of the b number plus or minus the square root of this entire thing, b squared minus 4 times the a number right here times the c number all over 2 times the a number, 2a. And again, I did this in a lot of steps this time. It'll get easier. So in the next step, I just squared the 12 and multiplied the 4, 5, and 3. I combined the 144 minus 60 to get the 84. I figured out what the square root of 84 was. Actually, let me move this completely. So the square root of 84 was 9.17. So now I'm going to break it into the two answers like we had. Negative 12 plus 9.17, which is the square root of 84, an approximation of the square root of 84. Negative 12 minus 9.17. And then you can type it right into your calculator. This quantity divided by 10, this quantity divided by 10. You'll get these numbers. And again, you can check them by putting it back in for x and seeing that they equal 0. In the next one, again, identified the a, the b, and the c. First check, does it equal 0? Identified the a, b, and c. I plugged them into the quadratic formula. I did 2 times 3, and I evaluated I did all this in one step on my calculator to figure out 133. And then in my calculator, I actually did this step, these two all at once. I'll show you that now, if I can get to it. So if you type it in like this into your calculator, you would do this, you would hit equals, and then the next time you would just go back and change this plus to a minus. So in a lot of your calculators, you should be able to do that. So that's how I got these answers. It makes it move a little faster than writing out all the steps, but I wanted you to see where the numbers came from. The next one, again, I identified the a, the b, and the c. Plug them into the formula. Again, notice the b was a negative 3, so when it's opposite of b, this leads with a positive 3. And when I do that, you'll see I end up with a negative under the square root. That's a no-go. You can't square root a negative number in Algebra 1. Later on you will. So our final answer here is going to be there's no solution. That means there's no number that we could plug in for x and make this expression equal 0. Over here it's very similar, so I'm hoping that you're trying these before listening to my explanation. If you haven't, try this one on your own. So this is your a, your b, and your c. Plug them into the formula. Use your calculator. And you get your answers here. You can check them on Desmos too. We looked at that in class, so if you'd like to see that, please come see me and I can show you how you can use the graphing to check it too. The next two look a little different. This one, it used to have, it was a trinomial, now it's a binomial. So we're just going to make b equal to 0. Again, we're going to plug everything into the formula. When I do that, I end up with a negative square root. This will not always happen when b is 0. So I don't want you to think just because b is 0 it means no solution. In this particular case it did. So this one is a no solution because of the square rooting a negative. This next one over here is actually the one that is wrong the most for people. If you try to use quadratic formula on this, you're going to get no solution because you're going to try to divide by 0. But notice, quadratic meant x was being squared. In this one, x isn't being squared. So a lot of people get stuck here and are like, oh gosh, I have no idea what to do. Well, go back to your previous year. You learned how to do this. You learned how to solve a linear equation. You add 1 to both sides, and you solve. So it's actually easier than you think. But so you need to know when to use quadratic formula. It's not just how to use it, but when to use it. And this, because it wasn't quadratic, you don't use it. In the next two, I'm not going to do the complete solution to them. I'm just going to show you. It starts off looking crazy, but remember our first requirement for quadratic formula is that it equals 0. So I canceled here. I made sure this equals 0 and this equals 0 by adding their opposites to both sides. And then once you get to here, then you would solve with quadratic. So you should be able to do that by now, or if you want me to check that later, you can. Again, this one looks really crazy. It doesn't equal 0, and I have this weird x plus 3 being squared. So the first thing I did was multiply x plus 3 quantity squared out, x squared plus 6x plus 9. Brought down the 2x, brought down the 2. Combined the 6x and the 2x. And then I made it equal 0. And after it equals 0, you just solve using quadratic formula. In this one, actually there are other methods too, but we're practicing quadratic formula now. In this one, in quadratic formula, this should equal 1. The a should equal 1. Even though we don't write 1 here, there is an a value of 1. So that should be the conclusion.